हेलो एवरीवन, गुड आफ्टरनून। दिस इज संतोष और आज हम लोग डिस्कस करने जा रहे हैं एजेंटिक एआई का एक नया चैप्टर। सो इसे हम लोग डिस्कस करेंगे। सो लेट्स स्टार्ट। सो एंटरप्राइज द इमर्जेंस ऑफ एजेंटिक एआई। सो agentic AI introduces in 23 to 24 and enterprise grade agent platform. The convergence of distributed software agent architecture and transformer based large language model culminated in the rise of agentic AI. So they introduces fully managed way to build goal driven tool using software agent by using foundations model from Amazon Bedrock. The model context protocol from the Anthropic define a method for the large language models to access and interact with external tools, environments, and memory. This is the key for the contextual, persistent, and autonomous behavior. These two milestones represent the synthesis of agency and intelligence. Agents were no longer limited to static workflow or rigid automation. So agents are more powerful uh, right now. So they are make the dynamic workflow and the dynamic automation. They could now reason across multiple steps, coordinate with tools and API. So with the help of API we can interact to that particular domain domain specific knowledge, right, through API, application protocol interface, maintain contextual state and learn and adapt over time. So in 2015, expanded enterprise capabilities, and in the first half of 2025, the agentic AI landscape expanded significantly with new enterprise capabilities. In Feb 2025, they releases the Sonnet, which was the first hybrid reasoning model on the market. So it is based on the reasoning. So they introduces Claude 3.7 Sonnet, and the MCP specification gained widespread adoptions. AI coding assistants such as Amazon's Q Developer AI. This is the AI artificial intelligence coding assistant. So Cursor and the Windsurf integrated MCP to standardize code generation, repository analysis, and the development workflows. The MCP March 2025 release introduced significant enterprise-ready features including OAuth 2.1 security integration, expanded resource types for the diverse data access, and enhanced connectivity options. So, through Steam Steamable HTTP protocol. So, this is the application level protocols. Some are the like FTP. FTP is the hardware related protocol where which we can upload the files and images and all. So file transfer protocol is there. But application level protocol is HTTP, Hypertext Transfer Protocol. Building on these foundations, AWS announced in May 2025 that was joining the MCP steering committee and contributing to a new agent-to-agent communication capabilities. This further strengthens the protocol position as an industry standard for agentic AI interoperability. So AWS strengthened customer options for building agentic AI workflow by open sourcing the standard stands agentic framework. So this provide independent and model agnostic framework enable developer to use foundation model across platform while maintaining deep AWS service integration. As highlighted in the AWS open source blog, stands agents follow a model first design philosophy that places foundations model at the core of agent intelligence. This makes it easier for the customers to build and deploy sophisticated AI agents for their specific use cases. So this is the emergence of agentic AI. The evolution of software agents from early ideas of autonomy to the modern large language model enabled orchestrations have been long and layered. What began with Oliver Selfridge's vision of the perceiving programs has grown into the robust ecosystem of intelligent, context aware, goal driven software agents that can collaborate, adapt, and reason. The convergence of the distributed artificial intelligence and transformer-based generative AI marked the beginning of the new era in which software agents are no longer only tools but autonomous actors in intelligent systems. Agentic AI represents the next evolution in software systems. It provides a class of intelligent agents that are autonomous, asynchronous, and agentic, and can act with delegated intent and operate purposefully within the dynamic distributed environments. Agentic AI unifies the following: the architectural lineage of the multi-agent system and the actor model, cognitive model of the perceive reason act, the generative power of large language model and transformers, the operational flexibility of cloud native and serverless computing. So software agents to agentic AI. So software agent, how can software agents shift to the agentic AI? Software agents are autonomous. So they have some model. Based on that model they perform the operation with less human invention. So it's a autonomous digital entity that are designed to perceive their environment, reason about their goals, and act accordingly. Unlike traditional software programs that follow fixed logic, agents adapt their behavior based on the contextual inputs and decision frameworks. This makes them the ideal for the dynamic distributed environments such as the cloud native systems, robotics, intelligent automations, and now generative AI orchestration. So with the help of generative AI, we can only generate the things based on text, images, and all. But with the help of agentic AI, we can automate the things. This section introduces the core building block of software agents and explain how these components interact within the traditional architecture based on the perceived reasons act model. So they perceive their reasoning, apply the reasoning, and act as a model. It's discuss how generative AI, particularly large language models, have transformed the way software agents reason and plan. This marks a fundamental shift from the rule-based systems to the data-driven learned intelligence of agentic AI. In this section, core building block of software agents, traditional agent architecture, perceive, reason, and act. Generative AI agent replacing symbolic logic with large language model. Comparing traditional AI to the software agents and agentic AI. Core building blocks of software agents. The following diagram represents the key functional modules found in the most intelligent agents. Each component contributes to the agent ability to operate autonomously in the complex environments. So this is the diagram. With the help of text, audio, or sensor, we perceive some perception is there. In last, we discussed the autonomy and that thing. So in this diagram, that is there, and perception is there, cognitive and action is there based on this diagram. So in perception, we take the text, audio, or sensors, and cognitive and the actions are interrelated. So action are based on the tools that is based on search, calculate, and execute. And the cognitive is the goal oriented, plan oriented, and decision making. So in plan we apply the reasoning and chain of thoughts, sub goals, breakdowns. And in learning there is the two type of memory which hold for the limited period of the time is called as the short term memory, and second one is the long term memory. So, in the context of the perceive, reason, act, loop, and an agent reasoning capability is distributed across both its cognitive and learning modules. Through the integration of memory and learning, the agent develops adaptive reasonings grounded in the past experience. As the agent acts within its environment, it creates an emergent feedback loop. Each action influences future perceptions, and the resulting experience is incorporated into the memory and internal models through the learning module. This continuous loop of perception, reasoning, and action enables the agent to improve over the time and complete the full perceive, reason, and act cycles. So, this is the perceive and reasoning based on some logic model, and some action is there. And so this is all about this cycle of above graph. So perception modules enables the agent to interface with its environment through diverse input modularity such as text, audio, and sensors. These inputs form the raw data that all reasoning and action are based on. Text inputs might include natural language prompt. So whenever we apply prompt, we give the instructions to a particular chatbot through text, images, and all. So and structure commands is there, and document we can also give the input through documentations also. So audio input encompass spoken instructions or the environmental sounds. Sensor inputs include physical data such as the visual feeds, motion signals, or the GPS coordinates. The core function of perception is to the extract meaningful features and representations from this raw data. This allows the agent to construct an accurate and actionable understanding of its current context. The process might involve feature extractions, object or event recognition, and the semantic interpretations, and the form the critical first step in the perceive, reason, act loop. Effective perception ensures that. So downstream reasoning and decision making are the grounded in relevant up-to-date situational awareness. Cognitive modules. So, cognitive modules serve as the deliberative core of the software agent. It is responsible for the interpreting perceptions, forming intent, and guiding purposeful behavior through goal-driven planning and the decision making. This module transform input into the structural reasoning process. So, this module is totally based on the reasoning, which enables the agent to operate intentionally rather than the reactively. This process are the managed through the three key sub-modules: goal, planning, and decision making. So goals sub-modules. The goal sub-modules define the agent intent and the direction. Goals can be explicit or implicit. So in a both way, goals are defined. In implicit way, they navigate to a particular location or submit a report. So this is the example of explicit, and implicit is maximize user engagement is implicit, or minimize the latency, and provide a target state for its planning and decisions. The agent continuously evaluates progress towards its goals and might prioritize or the regenerate goals based on the new perceptions or learning. This goal awareness keeps the agent adaptable in the dynamic environments. So planning submodule is there. The next module is the planning submodule, and then we discuss the decision making submodule. In planning some modules, we construct the strategies to achieve the agent current goals. So this is based on the agent particular goal. It generates action sequence and decomposes task hierarchically and select from the predefined or the dynamically generated plans. To operate effectively in non-deterministic or changing environments, planning is not static. So planning should be dynamic based on the reasoning. Modern agents can generate chain of thought sequence. So they are capable of doing the chain of thought sequence. Introduce sub goals are the intermediate steps and revise plans in a real time when conditions shifts. These sub modules connect closely with the memory and learning and allows the agent to refine its planning over the time based on the past outcomes. So decision making submodules. So the decision making submodules evaluate available plans and action to select the most appropriate next step. It integrates input from the perception, the current plan, the agent's goal, and the environment context. Decision making account for the trade-off between the conflicting goals, confidence threshold, for example, uncertainty in perceptions, consequences of actions, the agent learned experience. Depending on the architecture, agents might really or the symbolic reasoning. There are two type of reasoning is there. So logical and symbolic. So we reinforcement learning or the language model, large language model to make informed decisions. This process ensures keeps the agent behavior context aware, goal aligned and adaptive. Action module. So in action module, the action module is responsible for the executing the agent's selected decisions and interfacing with the external world or the internal system to produce meaningful effects. It represents the act phase of the perceived reason act loop, where intent is transformed into the behavior. When the cognitive module select an actions, the action modules coordinates executions through specialized submodules where the each submodules aligned with the agent's integrated environment. So physical actuations is there, integrated interaction is there. So in physical actuation for agent that are embedded in robotic system or Internet of Things devices, this submodule translate decision into the real world physical movement or hardware level instructions. Steering a robot, triggering a value, turning on the sensors. So integrated sorry integrated interaction is there. This some modules handle on the physical but the externally visible actions such as interacting with the software system platforms or API. So for example, sending a command to a cloud services, updating a database. So whenever we update the database, we hit the query, but this time we do some AI based updation, submitting a report by calling an API. So tool invocations agent often extend their capabilities by using a specialized tools to accomplish subtasks such as the following: search, querying structured or unstructured knowledge sources, summarizations, compressing large text input into the high level overviews, and calculation, performing logical, numerical, or symbolic computations. Tool invocation enable complex behavior composition through modular capable skill. Learning module. So learning module is there. In learning modules, the learning modules enable agent to adapt, generalize, or improve over the time based on the experience. It supports the reasoning process by continuously refining the agent internal models, strategies, and decision policy by using feedback from the perception and action. This module operates in the coordination with both short-term and long-term memory. So short-term memory is there, long-term memory is there. It stores transient context such as the dialogue states, current task information, and recent observations. It's help the agent maintain continuity within the interactions and tasks. So, long term memory encoded persistent knowledge from the past experiences, including previously encountered goals, outcomes of actions, and environmental states. Long term memory enables the agent to recognize patterns, reuse strategies, and avoid repeating mistakes. So, learning modules modes is there. Learning modes. In learning modes, the learning modules support a range of varieties such as the supervised, unsupervised, and the reinforcement learning, which support different environments and agent roles. So there are in last lecture we already discussed the supervised learning, unsupervised learning, and reinforcement learning through chart, pie, and diagrams. So we can go through that and we can interact with that particular video and we can learn from them. So in supervised learning, I will give the hint about the supervised and unsupervised learning along with the reinforcement learning. So supervised learning updates the internal models based on the labeled example, often from the human feedbacks or the training datasets. Learning to classify user intent based on the previous conversations. So, unsupervised learning identify hidden pattern or structure in data without explicit labels, clustering environmental signals to detect anomalies. So, in clustering, in what is the clustering? Whenever we uh, partition the software, like we have the server software, we have another type of software like a database software is there. So, we divide that particular software in the many forms is called as the clustering. So reinforcement learning optimize behavior through the trial and error. So it is totally based on trial and error basis to maximize cumulative reward in the interactive environments. So example, learning which strategy leads to the fastest task completions. Learning integrates tightly with the agent cognitive modules. It refines planning strategies based on the past outcomes, enhance has decision making through the evolution of the historical success, and the continuous improves the mapping between the perception and actions. Through this closed learning and feedback loop, agents evolve beyond reactive execution to become self improving systems that are capable of adapting to new goals, conditions, and the context over the time. So, this traditional agent architecture, we have an agent architecture which perceive and actions and act based on this text, audio, or sensors. So user or system request is there. Whenever we give the request and for a particular page or actions or perceptions reasoning, we can classify into the different way. So in this AI things, user hit the request and we get the perceive the text. We take the prompt or in chatbot like in text format, audio, or sensor. So it's apply the reasoning, and based on the reasoning, it's take that decision making based on the goals, plans, memory, and knowledge based. And then it's take the action to executions, tools, and actuators, and it's send back that particular response which is given by the user in the form of input or the request. Then it get back to the user in the form of response based on these three filter, perception, reasoning, and actions. So perceive modules act as an agent sensory interface with the external world. It transforms raw environmental input into a structured representation that inform reasoning. This includes handling multimodal data such as text, audio, or sensor signals. Text input may come from the user command, documentations, or dialogues. Input in the form of audio include spoken instructions or the environmental sounds. So sensor input capture real world signals such as the motion, visual feeds or the GPS. So this is based on the sensor. When the raw input has been ingested, the perceptions process performs feature extractions followed by the object or event recognition and the semantic interpretation to create a meaningful models of the current situation. These outputs provide structured context for the downstream decision making and anchor the agent reasoning in the real world observations. So reasoning second module is the reason module or reasoning module. The reason module is the cognitive core of the agent. It's evaluate context, formulate intent, and the determine appropriate actions. This module orchestrates goal-driven behavior by using both learned knowledge and reasoning. The reason module consists of the tightly integrated submodules. So memory is there, knowledge-based goal and decision making. So maintain dialogue is state, take constant and episodic history in both short-term and the long-term formats. So knowledge-based provides access to the symbolic rules and ontologies or learned models. So goal and plans are defined, desired outcomes and construct action strategies to achieve them. Goals can be dynamically updated and the plan can be adaptively modified based on the feedback. So decision making act as a central arbitrations engine by the weighing options, evaluating trade-offs and the selecting the next action. These submodules factor in the confidence threshold, goal alignment, and contextual constraints. Together, these components allow the agent to reason about its environment, update beliefs, select paths, and behave in a coherent, adaptive manner. The reason module closes the gap between the perception and behavior. So act module is there. The act module execute the agent selected a decision by interfacing with the either the digital or the physical environment to carry out tasks. This is where intentions becomes actions. These modules include three functional channels. So we have the three channels: actuator, execution, and tools. So actuator for agents that have a physical presence controls hardware level interactions such as the movement, manipulation, and the signaling. Execution handles software based action including invoking API, dispatching commands, and updating systems. And tools enable the functional capabilities such as the search, summarizations, code execution, calculations, and the document handling. These tools are the often dynamic and context aware, which extends the agent utility. The output of the ACT modules feedback into the environment and close the loop. These outcomes are the perceived by the agent again. They update the agent internal state and inform future decisions, thus completing the perceived reasons act cycle. So we have a generative AI agent. We discussed the agentic AI agent and agentic AI. In this section, we will discuss generative AI agent replacing symbolic logic with large language model. The following diagram illustrates how large language model now serve as the flexible and intelligent cognitive core for the software agents. In contrast to traditional symbolic logic system which rely on the static plan, libraries and hand-coded rules, LLM enable adaptive reasoning, contextual planning and dynamic tool use which transform how agent perceive, reason and act. So in this planning and goal orientation, the rest of the images are the same except this large language model thing. So in planning and goal, we have uh, feed the goal in the form of prompt. We we give the text and images to process. Internally, they use the large language model and chain of thoughts plan is fed as the prompt context. Model creates plan and subplan. So rest of the things are same as the last image, except this large language model. We perceive the text, audio, and sensor. We reasoning or reason through goals and plans, and we act as the curators, executions, and the tools. So key enhancement is that this architecture enhance the traditional agent architecture as follow. Large language model as the cognitive engines, tools used through the prompting and context-aware planning. So large language model goals, plan, and the queries are the passed into the model as the prompt context. The large language model generates reasoning paths, decomposes tasks into the sub goals, and decides on the next actions. Tool used through the prompting. Large language model can be directed through tool use agents or the reasonings and the acting prompting to call API and to search queries, calculate and interpret outputs. So context aware planning agents generate or the revise plans dynamically based on the agent's current goal input environment and the feedback without requiring hard coded plan libraries. So we have the prompt context as a memory. Instead of using symbolic knowledge bases, agent encode memory, plan, and goal as the prompt token that are the passed to the model. Learning through few shots in the context learning large language model adapt behavior through the prompt engineering, which reduces the need for the explicit retraining or the rigid plan libraries. Achieving goal long-term memory in large language-based models. Unlike traditional agents, which stored long-term memory in structured knowledge bases, generative AI agent must work within the context window limitations of the large language model. The extended memory that support persistent intelligence, generative AI agents use several complementary techniques, agent stores and the retrievals, augmented generations in context learning and prompt chaining and pretending. So agent store external long-term memories there. Agent states user history, decisions, and outcomes are the stored in long-term agent memory. So, agent states their history and decision making and their outcomes that is for the user input or we call as a request. So, that output will store in a long-term agent memory store, such as the vector database, object store, or document store. Relevant memories are the retrieved on the demand and injected into the large language model prompt context as a runtime. And this creates a persistent memory loop where the agent retains continuity across sections, tasks, or the interactions. RAG enhances large language model performance by the combining retrieved knowledge with the generative capabilities. When a goal or the query is issued, the agent search a retrieval index. The retrieved results are the appended to the large language model prompt, which grounds the generation in the external facts or the personalized context. This method extends the agent effective memory and improves reliability and the factual correctness in the context learning and prompt chaining. Agents maintain short-term memory by using instructions, token context, and structured prompt chaining. Contextual elements such as the current plan, previous action outcomes, and agent status are the passed between calls to guide behavior. Continued pretending and the fine tuning. For the domain specific agents, some agents are the domain specific. Large language model can be continued patterned on the customs collections such as the logs, enterprise data, or product documentations. Alternatively, instructions fine tuning or reinforcement learning how human feedback can embed agent like behavior directly into the model. This shift reasoning pattern from the prompt time logic into the model internal representations reduces prompt length and improve efficiency. Combined benefits in agentic AI. So, combined benefits in agentic AI. We have the combined benefit in agentic AI. And what are those? So, these techniques, when they are used together, enable generative AI agent to maintain contextual awareness over the time, adapt behavior based on the user history or the preferences, make decisions by using up-to-date factuals or the private knowledge, scale to the enterprise use cases with the persistence, compliant and explainable behaviors. By augmenting large language models with external memory, retrieval layers, and continued training, agents can achieve a level of cognitive continuity and the purpose that could not be achieved previously through symbolic system alone. Comparing traditional AI to the software agent and agentic AI. So we have the following table that provide a detailed comparison of the traditional AI, software agent and the agentic AI. Based on the example, we characterize the traditional AI as a spam filter. So like we have a Gmail. In Gmail, we have a spam filter. In traditional AI, we use the spam filtering. Image classifiers is there. Recommendations engines is there. So in search engine or in any type of engine, we have a recommendations. In software agents we have a chatbot. So chatbot is act like a agent, software agents. Task schedulers. So this chatbot we give the input and we take the output based on the software agent. Monitoring agents is there. In agentic AI assistant, autonomous deliver agent, developer agent, multi-agent large language model is there. In execution models, we batch or the synchronize, event-driven or schedules. Asynchronous, event-driven, and goal-driven. Autonomy, limited, often requires humans or external orchestrations. Medium operates independently within the predefined bonds. High act independently with the adaptive strategies. So we have a characteristics like a reactivity, reactive to input data, reactive to environment and events, reactive and the proactive, anticipate and the initiate actions. Proactivity is rare presence in some systems, core attributes, drives goal-directed behavior and communications, minimal, usually standalone or API bond. Inter-agent or agent-human messaging, rich multi-agent and human in the loop interactions. Decision making, model interference only, classification, predictions, and so on. Symbolic reasoning or the rule-based scripted decision, contextual goal-based dynamic reasoning after large language model enhanced. Delegated intent, no perform task defined directive by the user or partial act on the behalf of user or the system that have limited scopes. Yes, act with the delegated goals often across services, users, or the systems. Learning and adaptations often model centric, ML training, sometimes adaptive, embedded learning, memory, or the reasoning, for example, feedback, self corrections, agency, non tools for the humans, implicit or the basics, explicit operates with the purpose, goals, and the self directions. Context awareness, though stateless or the snapshot based, moderate some states tracking and high use memory, situational context, and environmental models. So we have an infrastructure rules embedded in the app or analytics pipelines, middleware or service layer components, composable agents, mesh integrated with the cloud, serverless, or the edge system. In memory, traditional AI is a tool-centric functionality narrow. Its focus on the predictions or classifications. So traditional software agents introduce autonomy and the basic communication, but they are often rule-bound or static. It is not dynamic. So agentic AI bring together autonomy, asynchrony, and agency. It enables intelligent, goal-driven entity that can reason, act, and adapt within the complex systems. This makes agentic AI ideal for the cloud native and AI driven futures. So, in this next step, this guide discuss the history and foundation of agentic AI. So, it's all about the agentic AI history and their foundations, which represent the evolution of the traditional software agents into the autonomous intelligent system that are powered by the generative AI. It describes how early software agents followed predefined rules and logic to automate tasks within the fixed boundaries, and explained how agentic AI built on this foundation by incorporating large language model which enable agents to reason, learn, adapt dynamically in open-ended environment. You can explore agentic AI in the depth by the reviving the following publication in this series. Operationalization agentic AI on AWS provide an organizational strategy to transform agentic AI from isolated experiment into the enterprise scales value generating infrastructure. Agentic AI pattern and the workflow on AWS discusses the foundational blueprints and modular construct used to design, compose, and orchestrate goal-oriented AI agents. So agentic AI framework, protocols, and tools on the AWS cover the software foundations, toolkits, and protocol to consider when you build your agentic AI solution. So building serverless architecture for agentic AI is also very important. In the AWS discusses the serverless architecture as the natural foundation of the modern AI workload, and describe how you can build AI native serverless architecture in the AWS cloud. So building multi-tenants architecture for agentic AI on AWS describes the use of AI agents in the multi-tenant settings, including hosting consideration, development, deployment models, and control plans. So this is all about the agentic AI, and we discussed the agentic AI. So if you like this lecture, you can like, share, or subscribe, and you can interact with previous lectures also. You can give the suggestion in the form of comments, so you can comment below to this particular video so we can make more user friendly and user engagement related videos on this agentic AI topic. So thank you for watching. So just enjoy these videos. Until that time, goodbye. Jai Hind, Jai Bharat.